This is the mathematics of class 7, chapter number 12, Algebraic Expressions. Introduction. We have already come across simple algebraic expressions like x plus 3, y minus 5, 4x plus 5, 10y minus 5, and so on. In class 6, we have seen how these expressions are useful in formulating puzzles and problems. We have also seen examples of several expressions in a chapter on simple equations. Expressions are a central concept in algebra. This chapter is devoted to algebraic expressions. When you have studied this chapter, you will know how algebraic expressions are formed, how they can be combined, how we can find their values, and how they can be used. How are expressions formed? We now know very well what a variable is. We use letters x, y, l, m, etc. to denote variables. A variables can take various values. Its value is not fixed. On the other hand, a constant has a fixed value. Examples of constants are 4, 100, minus 17, etc. We combine variables and constants to make algebraic expressions. For this, we use the operations of addition, subtraction, multiplication, and division. We have already come across expressions like 4x plus 5, 10y minus 20. The expression 4x plus 5 is obtained from the variable x, first by multiplying x by the constant 4 and then adding the constant 5 to the product. Similarly, 10y minus 20 is obtained by first multiplying y by 10 and then subtracting 20 from the product. The above expressions were obtained by combining variables with constants. We can also obtain expressions by combining variables with themselves or with other variables. Look at the following expressions are obtained: x square, 2y square, 3x square minus 5xy, 4xy plus 7. The expression x square is obtained by multiplying the variable x by itself, just as 4 into 4 is written as 4 square. We write x into x is equal to x square. It is commonly read as x square. Later, when you study the chapter exponents and powers, you will realize that x square may also be read as x raised to the power 2. In the same manner, we can write x into x into x is equal to x cubed. Commonly, x cubed is read as x cubed. Later, you will realize that x cubed may also be read as x raised to the power 3. X, x square, x cubed are all algebraic expressions obtained from x. The expression 2y square is obtained from y. 2y square is equal to 2 into y into y. Here, by multiplying y with y, we obtain y square, and then we multiply y square by the constant 2. In 3x square minus 5, we first obtain x square and multiply it by 3 to get 3x square. From 3x square, we subtract 5 to finally arrive at 3x square minus 5. In xy, we multiply the variable x with another variable y. Thus, x into y is equal to xy. In 4xy plus 7, we first obtain xy, multiply it by 4 to get 4xy, and add 7 to 4xy to get the expression. Terms of an expression. We shall now put in a systematic form what we have learned about how expressions are formed. For this purpose, we need to understand what terms of expression and their factors are. Consider the expression 4x plus 5. In forming this expression, we first form 4x separately as a product of 4 and x, and then add 5 to it. Similarly, consider the expression 3x squared plus 7y. Here we first form 3x squared separately as a product of 3x and x. We then form 7y separately as a product of 7 and y. Having formed 3xy, 3x squared and 7y separately, we added them together to get the expression. You will find that the expressions we deal with can always be seen this way. They have parts which are formed separately and then added. Such parts of an expression which are formed separately first and then added are known as terms. Look at the expressions for x squared minus 3x squared or 3xy. We said that it has two terms, 4x squared and minus 3xy. The term 4x squared is a product of 4 and x, and the term minus 3xy is a product of minus 3x and y. Terms are added to form expressions, just as the terms 4x and 5 are added to the form the expression 4x plus 5. The terms 4x squared and minus 3xy are added to give the expression 4x squared minus 3xy. This is because 4x squared plus minus 3xy is equal to 4x squared minus 3xy. Note, the minus sign is included in the term. In the expression 4x squared minus 3xy, we took the term as minus 3xy and not as 3xy. That is why we do not need to say the terms are added or subtracted to form an expression. Just added is enough. Factors of a term. We saw above that the expression 4x squared minus 3xy consists of two terms, 4x squared and minus 3xy. The terms 4x squared is a product of 4x and x. We said that 4x and x are the factors of the terms 4x squared. A term is a product of its factors. The term minus 3xy is a product of the factors minus 3x and y. We can represent the terms and the factors of the terms of an expression conveniently and elegantly by a tree diagram. The tree for the expression for x squared minus 3xy is shown as in the adjacent figure. Here, the blue figure, just draw in the right part, is the tree diagram for the expression for x squared minus 3xy. For x squared minus 3xy, there are two terms here that are 4x squared and the minus 3xy. And in the term 4x squared, there are three factors. There are 4x and x. Similarly, in the 3x, in the minus 3xy, in the terms minus 3xy, there are also three factors. They are minus 3x and y. And let's see another example. Minus 5y plus 10. Minus 5y plus 10. There are two terms. The first term is 5xy and the second term is 10. They are all the positive terms. In the 5xy, in the term 5xy, there are three factors. There are 5x and y. Let's see about the coefficients of an algebraic expression. What is the coefficient of an algebraic expression? We have learned how to write a term as a product of factors. One of these factors may be numerical and other algebraic. They contain variables. The numerical factor is said to be the numerical coefficient or simply the coefficient of the term. And here we find the coefficient of an algebraic expression. coefficient of the term. The numerical factor is said to be the numerical coefficient or simply the coefficient of the term. It is also said to be the coefficient of the raise of the term, which is obviously the product of algebraic factors of the term. Thus, in the 5xy, 5 is the coefficient of the term. It is also the coefficient of x and y. In the term 10x, y, z, 10 is the coefficient of x, y, z. In the term minus 7x square, y square, minus 7 is the coefficient of the x square, y square. When the coefficient of a term is plus 1, it is usually omitted or omitted. For example, 1x is written as x. 1x square, y square is written as x square, y square, and so on. Also, the coefficient minus 1 is indicated only by the minus sign. Thus, minus 1x is written as minus x, minus 1 x square, y square is written as minus x square, y square, and so on. Sometimes the word coefficient is used in a more general way. Thus, we said that in the term 5xy, 5 is the coefficient of x and y, x is the coefficient of 5y, and y is the coefficient of 5x. In 10x y square, 10 is the coefficient of x y square, x is the coefficient of 10y square, and y is the coefficient of 10x. Thus, in this more general way, a coefficient may be either a numerical factor or an algebraic factor of a product of two or more factors. It is said to be the coefficient of the product of the remaining factors. Let's see some examples. Example number 1. Identify in the following expressions terms which are not constants. Give their numerical coefficients. Expression xy plus 4. Roman number 1. Xy plus 4. In the expression xy plus 4, xy, the term which is not constant is xy, and the numerical coefficient is 1. Term which is not a constant is term which is not a constant in 13 minus y square is minus y square, and the numerical coefficient is minus 1. 13 minus y plus 5y square minus y, the 5y square are the term which is not a constant. Minus 1 and the 5 are the numerical coefficient. 4p square 4p square q minus 3pq square plus 5. 4p square q minus 3p square are the term which is not a constant, and 4 and the minus 3 are the numerical coefficient. Like and unlike terms. In the chapter factors, in the previous class we have learned about the like factors, like fractions, unlike fractions, and in the decimal also they are like decimal, unlike decimal. Here let us see in the algebraic expression what are the like and unlike terms. When terms have the same algebraic factors, they are like terms. When terms have the same algebraic factor, if they have the same algebraic factors, they are like terms. When terms have different algebraic factors, they are unlike terms. Let's see the example. For example, 2xy minus 3x plus 5xy minus 4. Look at the term 2xy and the 5xy. The factors of 2xy are 2x and the y. The factor of 5xy are 5x and y. Thus, the algebraic, that is, those which contain variables, factors are the same, and hence they are like terms. On the other hand, the terms 2xy and minus 3x have different algebraic factors. They are unlike terms. Similarly, the term 2xy and the 4 are unlike terms. Also, the term minus 3x and 4 are unlike terms. What is monomial, binomials, and trinomials, and polynomials? An expression with only one term is called a monomial. For example, 7xy minus 5m and 3x square 4, that is 4 is constant, okay, 4 etc. They are the monomials. So monomials means which have only one term. An algebraic expression which contains two unlike terms is called a binomial. In the algebraic expression which have two unlike terms is called a binomial. Let's see the example. X plus y, m minus 5, mn plus 4m, a square minus b square are binomials. The expression 10pq is not a binomial, it is a monomial. The expression a plus b plus 5 is not a binomial, it contains three terms. An expression which contains three terms is called a trinomial. For example, the expression x plus y plus 7, ab plus a plus b, 3x square minus 5x plus 2, m plus n plus 5, m plus n plus 10 are trinomials. The expression ab plus a plus b plus 5 is, however, not a trinomial because it contains four terms and not three. The expression x plus y plus 5x is not a trinomial as the terms x and the 5x are like terms. In general, an expression with one more terms is called a polynomial. Thus, a monomial, a binomial, and trinomial are all polynomials. Let's see some examples. Example number 3. State with regions. Which of the following pairs of terms are of like terms and which are of unlike terms? Roman number 1, 7x and 12y. Factors 7x, 7 and x, 12y, 12 and y. Algebraic factors same or different? Different. The algebraic factors are different here. Like terms or unlike terms? They are unlike terms because 7x, in the 7x the variables is x, and in the 12y the variable is y. So they are not like terms, they are unlike terms. In the remark also, here it explained in the remark, the variables in the terms are different. In the 7x and in the 7y the variables are different, one is x and another is y. If the variables are same, they are said to be like terms. And let's see another example. 15x and minus 21x. Factors of the 15x is 15 and x. Factors of minus 21x is minus 21 and x. Here algebraic factors are same and they are said to be like terms. Let's see the example. Let's see the exercise 12.1. In this exercise, all the questions are come from which are say constant, which are variables, and which are numerical coefficient. To find out the coefficient of the variables, to find out the coefficient of the numerical coefficient. So let's see question number 1. Get the algebraic expression in the following cases using variables, constants, and arithmetic operations. Subtraction of z from y. Subtraction of z from y. We have to subtract z from the variable y. So the answer should be y minus z. 1/2 of the sum of numbers x and y. 1/2 of the sum of numbers x and y. That means half into x plus y. The number z multiplied by itself, that is z multiplied by z, it should be z squared. 1/4 of the product of numbers p and q. The product of the p and q is pq, and 1/4 of the pq is written as 1/4 pq. Numbers x and y both squared and added. That means x squared and y squared, they should be added to each other. So we have to write as x squared plus y squared. Number 5 added to 3 times the product of numbers m and n. Product of m and n is mn, and their 3 times is 3mn. So the answer should be 3mn plus 5. The product of numbers y and z subtracted from 10. Product of y and z. Let us find out first. Let us find out the product of y and z. The product of y and z should be yz, and we have to subtract it from their product. Subtracted from 10. So 10 minus yz. Last, Roman number 7. Sum of the numbers a and b subtracted from their products. What is the sum of the number a and b? Sum of the numbers a and b should be a plus b, and subtracted from their product. What will be their product? Their product should be ab. So ab minus a plus b. Okay, the remaining questions will be available in the next video. For this video, let me conclude here. Thank you.